So as we all people knows that if we'll consider any two bodies in the universe, of course, so definitely based upon their masses as well as the distance between them, the force is acting between. So that is what we derive the formula. Mr. Sir Isaac Newton has given the derivation for universal law of gravitation, or we can say Newton's universal law of gravitation. That is what the force acting between the two bodies. Let the body is one is A and the body is B. Then the distance between them is what we consider, guys. Distance between them we used to consider as R. Then the force acting between them is equals to, as we know, it is a product of what, guys? Capital G into M1 into M2 divided by square of distance between them. So this is what the formula which we people studied for calculating the force of attraction present between any two bodies. Is it right or wrong, guys? Yes or no? So M means mass of the body 1, M2 means mass of the body 2. Or you can write the formula force is equals to capital G into capital M into small m divided by d square also. So in this case, what we are considering, body 1 mass is capital M, body 2 mass is small m, but the distance between them, what we are considering from their centers, that is very, very important. We are considering as a what? Distance is what we are considering, d. So in this case, we can use this formula. So both are same only, nothing different. So that is what we learned already. So force F is equals to force of attraction. Force of attraction, or we can say force of attraction, what is another name? Gravitational force. Or understand everybody? So gravitational force between any two bodies, or understand everybody, is capital G into M1 into M2 divided by R square. So now from this we derived the formula for G. What is the G value, G formula, everybody? Yes, please. What is the G formula, Mr. Arun Kailash? Force of attraction into distance, square of distance between them divided by M1 into M2. So this is what the G formula which we derived. And what is the SI unit of G? Anybody can tell me? What is the SI unit of G? Newton, force Newton, distance meter and power is their square per kilogram into kilogram square. This is what the SI unit of G. You cannot learn that one. Simple, just Newton square meter per kilogram square is the SI unit of G. What is G, guys? Anybody can tell me capital G. What is G? What is G?
Universal gravitational constant.
Gravitational constant. That is what, see, only one girl or one boy. Remaining will never open their mouth. Universal gravitational constant. Universal gravitational constant, capital G, is force into distance square divided by product of two masses. So now SI unit is this one. What is the CGS unit we studied? CGS unit of force is dyne, 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 and the distance is centimeter, so square centimeter divided by mass is grams. So gram means what? G square. Gram into gram, it will come G square. Is it yes or no, guys? Gram square. So that is what it is, the CGS unit. Dyne square centimeter per gram square. Yes, Harish?
Yes, sir.
No. This is what. So you cannot learn the two things. Force F is equals to capital G into M1 into M2 divided by R square, and G unit, universal gravitational constant. So it is a which quantity, Mitaksri, Divya? It is the scalar quantity, because it does not depend on mass or does not depend on direction, whatever it is. That is why G is called as universal gravitational constant, is called as which quantity, guys? Scalar quantity. Understand? So now today's class, we will study even what is the properties of this G also. That doesn't matter now. So first of all, you should learn this G value. It is universally accepted value and it is always remains constant. Every mind you should remember. Mr. Gokul Khanna, can you say what is the G value? G value, capital G, Kaushik. Arun Kailash, capital G is equals to, what is that?
6.67 into 10 power minus 11.
Yeah, 10
Newton meter
power
square
minus
divided by
11.
kilogram.
Newton square meter per kilogram square. If you are saying 10 times, why can't you remember that? That is what my question. So this value remains constant. Always this value remains constant throughout the universe, and this value is given by who has been given? Mr. Henry
Henry
Cavendish.
Cavendish.
Understand? So Mr. Henry Cavendish has been given this value. Understand? And this value is 6.6
Cavendish.
into 10 power minus 11 Newton square meter per kilogram square. This is what, please all of you remember that value. Without that, you cannot solve single numerical also in this chapter. Understand, Mr. Johan? Akilan? That is what. Now, so let us see that today's class we are going to study. The next one is characteristics of G. So after that, we people will proceed. What is happening? That is which I already studied, but of course, let it be make it. Write it. Characteristics of G. Which G? Capital G or small G? Characteristics of capital G. Again, small g will come. Don't get confused. That is why I'm saying now itself. Characteristics of capital G. So what is the capital G value, everybody? What is the capital G value?
6.67 into 10 power minus
10
11.
power minus 11 Newton square meter per kilogram square. Per kilogram square. Reading is also important. When you are opening mouth only, life will change. If not, it will never change. Continuously, I'm saying the same thing. But still, if you are not speaking, I cannot do anything. So first point. So as we know that this value remains constant or varies with Akshri throughout the universe, it is always remains
Constant, sir.
it is universe. If you'll go on the earth or on the Mars or on the Jupiter or on the sun or any other stars, wherever this G values remains constant. That is why we can say it does not depend on the medium between two bodies. It does not depends on the medium between two bodies. Medium means what? Medium means what, guys? It may be solid medium or maybe liquid medium or maybe gaseous medium, or we can say no medium. Solid, liquid, gas, or we can say no medium means vacuum. Vacuum, we can say. Is it okay? Divya, Harini, at least the chart you cannot put yes or no. That is what. Not ready to change what I can do. That's what. Right, next, second one. It does not depend on the masses of the bodies. It does not depends on the masses of the bodies. So means in the sense of what? Whatever the bodies, either bigger bodies or smaller bodies, doesn't matter. Always G value is what, guys? G value is what? Please
Constant.
yes, please. Remains constant. Understand, everybody? So that is why you can say the universal gravitational constant is numerically equal to the, understand, the force of attraction between unit masses placed at unit distances. That is already we derived and I have shown you also. Next, it does not depend on the distance between the bodies. That is a third property. Does not depend on the, does not depends on the distance between the bodies. Distance between the bodies. Understand, Mitakshri? So that is why the G value is always, you can consider, you can consider M1 is equals to M2 is equals to 1 unit. 1 unit means unit mass, and the distance between them is also 1 unit. Then what will happen, guys? Formula, tell me, if G is equals to force into, nobody will answer, R square divided by, understanding, 1 M1 into M2. So if we'll substitute, what will come here? F into R means 1 square divided by 1 into 1. So what will happen? G is equals to what?
F.
G is equals to F. We already solved or not this one? Do you remember Mr. Kaushik? Arun Kailash?
Yes.
Yes. That is what it is. So please make it. So G is equals to F. So means in the sense of what? The universal gravitational constant is numerically equal to the force of attraction between unit masses placed at unit distance apart. That is what it is. So please understand that. So G is equals to F. So it is not depend on what? Not depend on medium between two bodies, not depend on masses between two bodies, does not depend on distance between the two bodies. So it is always independent. That is why it is universal gravitational constant. And what is the value of that one? 6.67 into 10 power minus 11 Newton square meter per kilogram square. Is it okay, Mitakshri? I can only get response from Mitakshri or Hari. That's all. Remaining all I
Sir.
don't. Yeah, make it fast. So this is what the properties of characteristics of G. Make it, guys. Mr. Hari Jairas, you also the same thing. You also become like these fellows. No response, nothing. Please
No,
make it.
sir, I'm taking notes, sir.
Yeah. So this is what characteristics of G. So it is independent of everything. Does not depend on anything. Medium doesn't matter. Mass doesn't matter. And the distance also doesn't matter between them. That is what it is. Okay. So please write it. And here put one statement. G is equals to F. Put one statement. Universal gravitational constant is numerically equal to the universal gravitational constant. G is numerically equal to the force of attraction between what bodies, guys? Between unit masses placed at unit distance. Between unit masses placed at unit distance. Means the sense of what do you mean by unit? I told you. What do you mean by unit, Mr. Akilan, Gokul? One. Unit means one. One unit. One. Okay. Distance between them. Placed unit distance apart. So that is what G value. It will never depend on anything. Is it okay, Hari? Kaushik?
Yes, sir.
Yeah. This is all what is characteristics of G. Okay. So now, Mr. Johan will say what is the capital F formula. Can you tell me what is the force of attraction formula, Mr. Johan? I want to hear from your voice. I know that your mic is working, everything is working. I'll call you 2 times. Can you say the formula, Mr. Johan?
Sir, F is equal to
F is equals to
G into
capital G. Capital G into M1 into
M2
M2 divided by divided by
R square.
R square. What do you mean by R? Radius?
Distance, sir.
Distance between the two centers, object of the two centers. That is what. Very good. So now, shall we solve based upon this numerical or numerical? Everybody, are you ready?
Yes, sir.
Yes.
Sir.
That is what we need. So that is, you should learn it and you have to make it. So please make it fast and write it. Numerical is, write the question. Even you will be having example 10.1 in your textbook. So of course, let it be. Now you can write the question. So let us make the question, all of you. Calculate the gravitational force of attraction. Calculate the gravitational force of attraction. Calculate the gravitational force of attraction. This is what the question. All of you write the question. Calculate the gravitational force of attraction between a car of mass 600 kg and a bike of mass 100 kg separated by a distance of 20 meters. Separated by a distance of how much, guys?
20 meters.
Yeah. Make it fast.
Sir, in the place of G, you have to substitute that value, so 6.67.
So now they're asking what? Observe here very carefully. What they're asking, everybody read the question. They're asking calculate the gravitational force of attraction. Gravitational force of attraction means what is the symbol we have given for this? F. Understand? And they're saying two. One is car, another one is bike. So means one object is car. Understand everybody? And another object is bike. So now you can take. So this is bike. So that what is the distance between them? They are separated by the centers. What is the distance? Distance is equals to 20 meters. And car mass, M is equals to 600 kilogram. And car bike mass, what is the bike mass?
100 kg.
So 100 kilogram. Okay, that is what. So they are asking force of attraction. So given, neatly how to write it, given mass of car is equals to mass of car, you can assume capital M or M1, your choice, 600 kilogram. Next, mass of car M2 is equals to, sorry, mass of car not, mass of bike
Bike.
M2 is equals to 100 kilogram. Next, distance between them R is equals to how much? 20 meters.
20 meters.
Understand everybody? That is what it
Yes,
is.
sir.
Next, they're asking calculate the force of attraction F. So we know that all will be silent. Harini will say, Harini, what is the G value? We know that capital G value. What is the capital G value? Yes, Harini, can you hear me? I know you can speak. What is the G value? Mr. Gokul? Unless you will say
6.67 into 10 minus or
6,
minus 11.
10 power minus 11. That's all? No unit?
So nano
No. Wow. Oh, horrible, Rama. Oh, this is. Nano. Very good, very good. Super. Yes, please respond. Tell me. Newton square meter per kilogram square. You cannot learn that, Mr. Gokul. Newton square meter per kilogram square. Like LKG I'm teaching. You're saying nano. Tomorrow you can say some other thing. Is it okay, Gokul? That is what. So now, what is the force formula? Everybody, Divya. So capital G into M1 into M2 divided by R square. So that's all. So simplification is very, very complicated. That is why numericals are very, very tough. So solve it neatly. G value. What is the G value, guys? 6.67.
6.67 into 10 power minus 11. Minus 11.
Substitute the units. Don't substitute the units. We know that what is the force units? What is the units of force? Unit of force, guys.
Newton.
Newton. So final answer.
Newton, sir.
Final answer is just to keep the newtons. That's all. Nothing is there. So 6.67 into 10 power minus 11 into mass of body 1 car. How much?
600 kilograms.
M2 100 divided by R square. R square means what? 20.
20.
20 square.
That is what. So simplification I will teach you. See. So keep it 6.67 as usual. 10 power minus 11 into. Can I write 600 as 6 into 100? Is it okay, everybody?
Yes, sir.
Yes, sir.
100 only. Any doubt? 600 I am writing as a 6 into 100. I am trying to make simplification yours. Now 20 into 20. How much, guys? 40?
400, sir.
400.
400.
Understand? Square it is 400. So keep it as a 400. Now you can notice it. F is equals to. I will try to remove 100 ones. 100 watt. 100 watt, guys.
4.
4.
4.
Simplifying, I will go very slowly only, no issues. 6.67 into 10 power minus 11 into 6 into 100 divided by what? 4. Is it okay, guys? Everybody?
sir.
Okay, sir.
Now, you can see 2 threes are 2 twos are. See, this is not, don't get confused again. Okay, this step. So, what is remaining? Next step, tell me. 6.67 into
0.6.
10 power minus 11 into, what is that? 3 into 100 divided by 2. Is it okay, guys? Is it okay?
Yes, sir.
Yes, sir.
Yes, sir.
2 ones are 250s are. Is it okay, Mitakshri? 2 ones are 250s are. Now, numerator is completely gone. Yes or no? Denominator is completely gone or not?
Yes,
or
sir.
no? That is what. So now, be very careful. 6.67, keep power last, into 3 into 50. Next, into 10 power minus 11. That's all. So now, multiply everybody 6.67 into 3. How much value? Tell me fastly.
1000.5, sir.
Yeah, let it be. First, let them do the 6.67 into 3. Mr. Johan, do it seriously. 6.67 into 3. How much? I want to know the answer. Everybody.
20.01, sir.
20.01 into 50 into 10 power minus 11. Now, you can see which we can. Now, 20.01 into 50. Multiply it, everybody.
1000.5, sir.
1000.5, sir.
1000.5 into 10 power minus 11. Is it yes or no?
Yes, sir.
Yes, sir.
Yes or no? Yes or no? All of you. Now,
Yes, sir.
all of you observe very carefully. Now, in mathematics, if the power, if now I want to decrease this power, suppose if the decimal will move forward, then what will happen? Power will decrease or increase? Power will decrease or increase? Here,
Dec-
correct. So let it be.
Decrease, sir.
Observe very carefully. Now, 1000.5, can I write it as a 1.00005 into 10 power 3? Is it right or wrong? Is it right or wrong?
How?
Yes,
How?
sir.
How? The question. Now again multiply 10 power 3 means what? 1.00005 into 10 power 3 means what? 1000. Is it okay, Ma? Yes, please. All of you.
Yes, sir.
So now you multiply this one, you will get again 1.000, sorry, 1000.5 will come. Is it right or wrong? Verify, everybody. Yes, please. I am writing just in the form of powers. Is it okay, guys?
Yes.
Please.
Sir, teach again.
1000.5 I am writing as the 1.0005 into 10 power 3. Nothing I am doing. Just dividing
But
with
how,
the,
sir?
I am dividing with the 1000. Just 1000.5 I am dividing with the 1000. So that what will happen?
Oh, okay, sir.
Do you understand?
Yes, sir.
So that the decimal will come here. Nothing is there. Do you understand, everybody? Yes or no?
Sir, how you are doing this, sir?
Yes, Mr. Omar. I am multiplying and dividing with 1000. Is it okay, Omar? Now, are you happy? I am multiplying
Okay.
1000.5 with 1000 and 1000 both. Is it okay? Wow. Actually, I should not say this, but what I can do? My 9th class, but still I have to say. I am multiplying the 1000.5 with 1000 divided by 1000. You understand, everyone?
Yes, sir.
Yes. Now, 1000 means how I can write? 1000 means can I write it as a 10 into 10 into 10? Is it right or wrong? Yes, sir. Everybody? Yes, please. So 10 into 10 into 10 means 10 power 3. Now do this division. Do this division means 1000. 3 zeros means the point will move to 3 zeros front. Is it right or wrong?
Yes, sir.
Yes. Is it okay? Everybody? Respond.
Yes, sir.
I am just changing the power. Nothing is there. I am not doing any other thing. Now into 10 power 11 is still remaining. Is it okay, Omar?
Yes, sir.
Yes, sir. Understood, sir.
Everybody have you understand?
Yes, sir.
I'm writing just in the form of powers. Nothing here. This power will go, this decimal will go to 3 Ds before, then it will become 1000. 1000 will come. This 1000 only I am writing as a what? 1000 I can write in the form of multiples of 10. 10 into 10 into 10, 10 power 3. Understand, Mr. Gopal, Akilan, everybody? That is what.
Yes, sir.
Now force F is equals to. Now you can see powers. Base is same. Mathematics. A power m into a power n. So what is the formula? A
A
power
power m plus
n. So the same way here. So 1.0005 into 10 power 3 plus minus 11. So which is equals to 1.0005 into 10, 3 plus into minus minus 11. So plus 3 minus 11. What is the answer, Mitakshri? Plus 3 minus
Minus 8.
Minus 8, sir.
minus 8. That's all. So that is what to make it simplified. I have done this. And what is the unit of force? What is the unit of force?
newtons.
Newtons. That is what it is.
Newton.
Answer. So I understand now, Mr. Omar.
Yes, sir.
Yes,
Great.
sir.
Everybody solve it now. This is
Sir,
what.
why, sir? Still we can simplify, right?
No need to simplify. Always in physics, the beautiful way of writing answer is in powers. Understand, Mr. Omar?
Okay. Yes, sir.
Yeah, you can write it if you want 0.0000000001 again 0005, but it's not the way of writing answer in physics. Is it okay? Solve it now neatly.
Okay.
I will understand everybody. Harini,
Yes, sir.
Divya,
Yes, sir. Yes, sir.
write it. Simplification is always matters. Now, if you really understand this sum, then let us go back to our NCERT book. NCERT book, all of you open. Solve this sum first. I hope everybody understand. Everybody will solve. Mr. Akilan, Arun Kailas will never solve. I know that. Solving, Mr. Arun Kailas.
Yes, sir.
Yes. Now, those who solve this sum, write 10.1. Meeting is going to end. Get back everybody and write 10.1. Divya, if you understand, you can get back and go. You can leave. Yes. 10.1 example, everybody will write. We'll solve that, then only we'll wind up. Everybody write the 10.1. NCERT book, page number 134.